Alright, so now from here, what we're going to do is learn all about this third rule of how to solve a system of equations. We've been focusing on the elimination method, we've been focusing on the substitution method, and specifically more the elimination, but still. We've been focusing on those two methods, and now we're finally going to go to method number 3, which is the matrix method. And before we can start this method, just some key points to know is that, first of all, you got to make sure every equation is in the form of this ax plus by equals c, meaning your variables are on the left, your number, your constants on the right. Okay? And then I gave you an example. What a matrix is, really in a nutshell, is it takes your system of equation and focuses on just the coefficients. It uses, right here, it uses the coefficients to make a matrix. So if you have it set up in the correct form, where all the x's and y's are on the same side of the equation, you just start picking off. Okay? Where 2, -3, make sure you take a sign in front of it if it's something other than positive. So that's why I make sure I get -3 in there, and 5. 1, 4, and 1, and -1. And notice that when you do it like this, all of your coefficients that are in front of the x variable will be in this first column. All of your coefficients that go with the y variable will be in your second column. If there was a z variable, then you would have another column right here with all the coefficients of the z. And then after this long bar that I have written right here, the bar just kind of helps separate the coefficients of the variables from what they're equal to, the constants on the right. So here's treat that as like your equal sign, and then here is what your equations were equal to. Okay? And when we're solving a system of equations using the matrices method, our goal is to take it from this form where we have just a bunch of random numbers in there to specifically this form, where I have a 1 in the top left, a 0 below it, a 1 in the bottom right, and a 0 above it. So in other words, 1's along the diagonal and 0's everywhere else. And that is your key whenever you're solving with matrices. And you could be sitting there going, how do you make that happen? Well, that's the whole thing. I'm going to show you step by step on how to get specifically 1's along the diagonal and 0's everywhere else, and it has to be in a very specific order. So let's go here with the first example. In this example 8, all we're wanting to do really is just practice on just setting up a matrix first of all. We're not going to worry about solving it yet, we just want to set it up. And so looking at this, remember it says you want all your variables on one side, everything else on the other. And if a variable is missing, put a 0 for it. So in this first equation, I don't have any x's, so I'm going to put 0x. And I have minus y plus 2z equals 6. Second equation, looks like I got my x's there, I've got my y's there, got my z's, and equals a number. Second equation was great. Third equation, gonna have to move that variable over, huh? I don't have any x's. I've got 3 y's. When I move the z's over, they become positive, so 4z. And then after I moved them over, there was nothing left on that side, so it just equals 0. Okay, so let's set up this matrix then. There's my dividing line to separate the coefficients on the variables to what the constants they're equal to, which are 6, 7, and 0. And then just listing them off. So coefficients on the x's are 0, 2, and 0. The coefficients on the y's are -1, making sure I get my negative in there, a 2, a 3. Then on the z's, it'd be a 2, a -8, and a 4. And that's my answer right there. This is known as an augmented matrix. Okay, augmented just meaning it's basically taking a system of equations and just focusing on the coefficients. Right? Over here in example 9, what we want to do is just kind of go backwards. Here's my augmented matrix. Let's go back and write the system of equations. Okay, looking at the columns, looks like I've got a total of 4 columns. So these are always my constants, what the system's going to equal in each of the 3 cases. And then variables out, so x, y, and z. So that first row is going to be 1x, or just x, a positive 3y, positive 2z is equal to 4. All right, second row, I've got 2x. I don't have any y's, I don't have any z's, so it just equals 5. And then that third row, 3x minus 3y plus 2z equals 6. And that's it. There's the original system. That if I went that way, I would write that for the augmented matrix for that system. And then here on this one, Here's my x's, here's my y's. My bar tells me I'm done because this is what my system's going to equal right there. So x plus 3y is equal to -4, and negative x plus 2y is equal to 5. And that's what we got for that one. Okay, let's go on to example 10. Here in example 10, what it's doing is it's kind of now we know how to form our matrix. It's showing you in a hand-by-hand, step-by-step on how we're going to actually get that solution. Just remember, our goal is to, every time we try to solve a matrix, no matter how many variables I have, your goal is to get ones along the diagonal and then zeros everywhere else. Okay? And then these will just be some numbers, and we'll come back to that. And this one's telling you exactly what to do. So here's my starting augmented matrix. And this right here is telling you the operations you're going to do. What we're going to start with is we're going to take -2 and multiply it to our row 1. That's how you read that. -2r1 means -2 times row 1, and then we're going to add it to row 2. So -2 times all of this row 1, all of this up here, and we're going to add it down. Okay, so notice if we go to this matrix here on the right, notice row 1, it's still the same. It hasn't changed. What we're doing is by doing these steps right here is we're changing row 2. Whatever is listed second is what's really changing. All right, so -2 times 1, it's like what we're going to be doing is distributing this in here, not really changing anything, and then we're adding it down, okay? So -2 times 1 is -2, plus 2 is 0. And I'm adding because it tells me -2 times row 1 plus row 2. And we have to go x to x, y to y, z to z, or so forth. Okay? Now let's go to the second one. So the y. So -2 times +2 is -4. -4 adding on 3 is a -1. Lastly, -2 times 1 is -2. And -2 plus a -1 is -3. All right, so we're kind of working here with some of our augmented matrices. And we have a brand new kind of manipulation of it. So let's go to the next step. The next step just says all I want to do here is change the sign of row 2 or multiply row 2 by -1. Well, row 1 staying the same, so -1 times everything in row 2. Well, there's 0, now +1 and +3. All right, let's take 2 seconds before we go on to the next step. Look here. I've got a 1 on the diagonal, a 1 on the diagonal, so that's checking off with that and that. I have a 0 down here in the bottom left. All we need is that right there to be a 0, and I've got supposedly my solution matrix. So what this next step is doing here is trying to get a 0 in that top right position. So it's telling us we want to take -2, multiply it times row 2. Okay, so I'm going to multiply everything here, all of this basic row 2. We're going to multiply it by -2, and we're going to add it up to row 1. Okay. The last one here is the only thing that's changing. That's why if you look here, down here on the bottom, row 2 is the exact same row 2 as we have right there. It's definitely the same. Okay, let's do what we did before. -2 times that x value, adding it up. So -2 times 0 is 0 plus 1, 1. -2 times 1 is -2, plus 2 is 0. And -2 times 3 is -6, plus 1 is -5. Well, look right there. We have exactly what we want. We have 1s along the diagonal. We have 0s everywhere else. We can write our solution. If I asked you to describe this first row, if I wanted you to write that back into original, like a linear, write an equation for it, you would say 1x plus 0y is equal to -5. Well, 0y doesn't mean anything, so it says x equals -5. Look, we found a solution for x. If we come to the second row, 0x plus 1y is equal to 3. Well, look, that doesn't mean anything. Y equals 3. It checks off. And there's our solution. If you want to write it in a coordinate form, it would be -5, 3. So let's box that up, and we can call that done. And what I'm going to want you guys to do is actually to be able to do this whole process right here, and you have to decide what you're going to be doing to each row, how you're going to be doing rows, how you're going to add them up, and all that. So obviously we're going to get some practice. So let's go on to example 11.